Hi and welcome back to my channel, and this week's problem just before Christmas is trying to find the area of one of these green squares. Now we've got one of the lengths, as you can see, labelled on the diagram as 4, and that is from where this green rectangle made up of 4 green squares touches the yellow square, the top of the yellow square, when it's tilted, as you can see in that fashion. Okay, that's the problem. Can you find the area of just one of those green squares? If you want to have a go at this problem yourself, here are some key points labelled that you might want to use in your solution when you put it down in the comments below. Otherwise, I'm going to go through my solution in 3 seconds. So pause the video now if you want to have a go yourself. Otherwise, I'm going through my solution in 3, 2, 1. Okay, so what I did to solve this problem is I started off by labelling this side x, and then with that I know that the length of the yellow square is 4 plus x, so I labelled those on. Now I then wanted to have a look at these triangles, and if I labelled this angle, as you can see, alpha, then this angle must be 90 minus alpha, because we've got a right angle at the bottom of that square, or in the corner of any of the corners of the square, I should say, which means that this angle in the triangle would be alpha also. Now what that means is these two triangles on the right hand side of the yellow square and on the bottom of the yellow square are going to be similar triangles, and that's important. That means that the ratio of the sides, the corresponding sides, are equal. Okay, so I then labelled the length of the green square as y, and if one of those is y, then we've got this is going to be 4 lots of y, or 4y, and then we can start dealing with these corresponding sides of these similar triangles, and we get this equation, and that is 4 plus x divided by y is equal to 4y over x. Now where I've got that from is this bottom triangle, the hypotenuse of that is 4 plus x, and then the perpendicular height, if you like, from it depends what you call the base, but we've got a height of y, so the hypotenuse divided by the height is equal to, on the right hand side triangle of the yellow square, now the hypotenuse, which is 4y, divided by the height, which is x. Okay, now those heights correspond. I'm aware I'm saying heights, and that could be interpreted in different ways, but hopefully you can see that the corresponding sides there are x and y of those two triangles. Now we need to rearrange that to get x brackets 4 plus x is equal to 4y squared, and we could expand the brackets like I have there. So 4x plus x squared is equal to 4y squared, and that's our first equation. Now we've got two variables here, so we are going to need a second equation. And where can we get that from? Well, we have got a couple of right angle triangles, so we could use Pythagoras to give us that second equation. And if we use the triangle on the right hand side, we get x squared plus 4 plus x in brackets squared is equal to, in brackets again, 4y squared. Now if we expand the 4y all squared, we get 16y squared, and we're nearly at the point now where we can use these two equations, but the problem is one of them is equal to 16y squared and one of them is equal to 4y squared. So let's multiply our top equation here by 4, so everything by 4, and we are going to get 16x plus 4x squared is equal to 16y squared. Now what we can do is because they're both equal to 16y squared, I can replace the 16y squared in the first equation with x squared plus 4 in brackets 4 plus x all squared. That gives us this, and we then need to start rearranging this, and the first thing we can do is we can subtract x squared from both sides. The next thing you'll want to do is expand this bracket, and that gives us x squared plus 8x plus 16. From there, what we're going to do is we're going to get everything onto one side. Because we're going to have a quadratic, we can see that, but we have to make it equal to 0 to be able to solve it. So let's do that, and we get 2x squared plus 8x minus 16 is equal to 0. Now all of those numbers are divisible by 2, so divide them by 2. We get x squared plus 4x minus 8 is equal to 0. Now from there you can use quadratic formula to solve this, get a solution, and that gives us an answer of x is equal to minus 2 plus or minus 2 root 3. Okay, now we're getting close because we've got a value for x. We can go back to this equation from earlier. This is probably the most simple equation. So we're just going to substitute in for x here. Right, now this is only the left-hand side at this point, but when we substitute our value for x in, whether we use the plus or the minus, so we've got two solutions, doesn't matter which one we use, we get a value of 8, which is crazy it seems like. How can we get a value of 8 from there? But we do. We do get a value of 8, and that is equal to 4y squared. Now, we want the area of the green square, and that has got a length of y, so we're really looking for y squared here. Divide both sides of this by 4, and we get our answer, which is 2. Now, that's a really neat answer for basically a problem where the yellow square would have a really complicated width. I think it would have 2, from memory, 2 plus or minus, go back very quickly. It would have a length of 2 plus or minus 2 root 3. But yet y, or y squared, y is root 2 and y squared is 2. That's a really crazy answer, it seems like to me. Let me know down in the comments below if you managed to get this solution, and let me know especially if you managed to get it a different way, because I'm always interested to see, and everybody is, I hope, reading the comments, a different solution. If you like this video, please like the video, please drop a like on the video, and if you're not already, please consider subscribing to the channel. I put out a new problem solving video at Monday 5 PM every week. Thank you for watching, have a great week everybody, Merry Christmas, and I will see you next week for another video. Until then, bye bye.